Your cure's worse than the disease, plus you took an oath too. And so I say now, shut up, Fauci. Fauci, shut up. Oh, fancy meeting you here at the Daily Space Weather. And welcome. I'm your host, Dan, a.k.a. smAsho. We're looking at the northern hemisphere of the sun to see the degradation of sunspot 2811, which will lose its name today. There it is. You can see the umbre vanishing just to the right of my arrow there. Sunspot 2812 remains the only sunspot on the Earth-facing portion of the solar disk. Chance for coronal mass ejections continues, folks. So we'll be keeping an eye on that. And when I say eye on, well, the pun is intentional. We'll also be talking about Hoinga, Hyades tidal tales, and some weather. By the way, if you haven't seen Fauci Shut Up yet, check that out. We have a playlist, youtube.com/smashamash/playlists. And if you didn't see yesterday's Daily Space Weather Supplemental, we covered the coronal mass ejection that you can see here on the screen. Don't be surprised to see us reporting soon on that ejecting as well. And so perhaps check that out if you haven't seen that. Let's take a look at Lagrange point 5 for some current data. Lagrange point 5, the location of stereo A, viewing the sun from several weeks behind the Earth, orbitally speaking. And we'll re-show this coronal mass ejection. Check it out. And this object here, which, by the way, thanks to Mandy Heslin, we emailed stereo A's webmaster and the person in charge of the instrumentation about this, as that does not have any of the properties of Jupiter. Apparently stereo A reporting that that is Jupiter, yet somehow Jupiter, being on the opposite side of the sun, seems to be moving left to right in the imagery. So as you can see, it looks like it's accelerating, and it's actually changed its course a little bit there. And it looks like it may be interacting with the plasma as well. You can see there's like a shell around it there. Perhaps the object has a magnetosphere. Maybe it's a Borg sphere, folks. But in any case, there's the current data from stereo A. I'll let this play through. We've gone back 100 frames. Little tutorial. When you bring this down, 100 frames is the most you can have. And you can increase the temporal resolution of that. We left it at 3 frames per second. We'll let it play through for your visual amusement. And again, the likelihood of additional coronal mass ejections in the Earth-facing vicinity remains. We'll let you know if it becomes imminent or when it becomes imminent. I'll say if it becomes imminent. And here is the view from Lagrange point 1. The SOHO spacecraft includes 2 coronagraphs, the LASCO C2 and the LASCO C3. And when you look at this ejection, it may look like a halo ejection, the kind that is headed toward Earth. But again, I assure you, it's on the opposite side of the sun, as we just showed you in the stereo A imagery. Continuing on, just to show you the diagram here. So stereo A is located someplace around here. Stereo B is located someplace around here. So while it does have a fairly straight line view to Jupiter, Jupiter orbits the sun in this direction, folks, which means it would be moving from right to left, not from left to right on the stereo A imagery. We'll be keeping an eye on our email to see if we get a response on that. Here's a full disk view of the past 24 hours of the closest star, El Sol, the local yellow dwarf known as the Sun. And indeed, many names it has. Here's another view in a different UV bandwidth. This is 193 angstroms. The previous was 171 angstroms. We're expecting a coronal hole wind stream to show up from this series of 3 coronal holes here. And it's going to show up sporadically in pulse-like strikes. We'll show you the NOAA forecast momentarily. Here's 304 angstroms, ionized helium, the best wavelength at showing you filaments. And there are indeed filaments right in this area, which NOAA and NASA are missing for some reason. We'll show you the lack of that data a little bit later in the video. And let me just check the life of the stream before we move on to show you a star chart. I like to use in-the-sky.org. I have mine set so it shows me if it's light or dark out. I face mine to the south and I draw in the ecliptic. If you're up before dawn, you may see Saturn and Jupiter and Mercury all rising ahead of the sun. Venus and the sun practically overlapping right now as we see a daytime planetary pileup in the sky. The 10.7 centimeter radio flux, the output of the outer chromosphere and the lower corona, just this area, folks, it puts out radio emissions. Yes, photons in the frequency of radio band. The band we're talking about is 2800 megahertz, otherwise known as 10.7 centimeters, and that radio flux is at 80. Here it is in context, a one-year chart. The top black line is the 10.7 centimeter radio flux. The red line here is the sunspot number. And again, we've lost a sunspot. Sunspot 2811 will lose its name today. And here's the NOAA forecast for geomagnetism. We're expecting, according to the NOAA forecast, at least a pulse early tomorrow and a pulse late on Monday the 29th. So you can see a series of geomagnetic storms and geomagnetic unrest over tomorrow and Monday, rather. Tomorrow and Monday, the 28th and 29th, expected to show up with some geomagnetic storms and geomagnetic unrest. Fairly minor. Those coronal holes have evolved over time here, so we could see quite sporadic pulses from that South Pole-oriented coronal hole wind stream. Here is the Fagradalsfjall. Have you learned to say it yet? Come on, folks. Say it aloud. Fagradalsfjall. 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 It's not actually that hard to say, but in any case, there it is. The Icelandic volcano looks like it's filling up the valley in which it lies and becoming a shield volcano as we watch it evolve in real time. A fantastic little geological lesson here as we watch real-time imagery of the Icelandic volcano. Fagradalsfjall. A great Viking name. Next, looking at the rest of the volcanoes that are erupting. We've covered the fact that Fagradalsfjall is sort of erupting. Not in a spectacular fashion right now, but it's on the list. At least on my list. Also Sakurajima, the Japanese volcano producing a 7,000-foot ash plume. Mount Raung on East Java. It would not be wrong to say Raung is producing a 12,000-foot ash plume as it explodes. Dakono also exploding on the Isle of Halmahera. 7,000-foot plume there. Pacaya volcanic ash not observed in satellite. Please don't pole vault the caldera. Sangay in Ecuador exploding. 20,000-foot ash plume there. That's an uptick in Ecuador. Revenador also exploding. The other Ecuadorian volcano on the list. 15,000-foot ash plume above it. And explosive activity at Sabancaya, the Peruvian volcano, enough to produce a 25,000-foot plume of ash. Please do not square dance around the caldera or attempt to tightrope walk it. Here is the earthquake rundown of the past 24, and we don't see any major quakes. We're going to scroll up the list. We reported on a bunch of deep quakes yesterday. No major earthquakes yesterday either. And we're just going to scroll up the list here. There was one in the northeasterly portion of India at a 5.1 magnitude there. Largest of the past 24, I think, was this 5.9, a deep quake at Japan at over 150 kilometers depth. There was also a 5.7 earlier than that, very far south, at the plate boundary between the South Pacific plate and the Antarctican plate. Deep quake struck the Dominican Republic, the Isle of Dominica. That was a 4.3 magnitude at 123 kilometers depth. And pardon the lateness today, folks. We slept in. We'll tell you later about why. 4.9 at Indonesia was a deep quake as well as a 5.0 at Indonesia. So again, no major quakes over the past 24. A nearly 6 magnitude quake at depth did strike Japan. Here's some more solar data for you here. It's the GOES X-ray flux, and we didn't see any major solar flares over the past 24. Largest of the past 3 days was this nearly C-class flare, and a couple minor incidents here. I don't even think that qualifies as a B-class solar flare. And again, we saw sunspot 2811 degrade down to the point where it's going to lose its name. It has no ombre anymore, folks. It's now a plage, an active region. Not to be confused with a plague of nonsense on YouTube. Here's the proton flux over the past 3 days. No strikes in the proton flux there. We would have let you know if there was going to be one. The GOES magnetometer over the past 3 days, also measured by the GOES 16, just like the X-ray flux and the electron flux. And we see pretty high lows here over the past 24 hours, having only reached down to around 74 nanotesla there near midnight local time for the satellite, which is what that M means. Here's some more magnetic data. It's the polarization of the heliospheric current sheet. And for a moment there, the entire portion of the Earth latitude current sheet was at South Pole. You can see right here, the entire current sheet at the Earth is South Pole oriented. And this data is based on ground-based magnetometers here on planet Earth, as well as on stereo A at Lagrangian 0.5 and stereo B at Lagrangian 0.4. In any case, Earth expected to solidly remain in the South Pole current sheet. Here's a line of sight field plot. This shows you the sun's B field in blue. As the sun takes its good old time performing the solar cyclical solar polar field reversal, B field looking very much like solar minimum conditions, despite being a year and a half into cycle 25. So here's a lack of data. For some reason, the filaments imagery is not showing filaments in this area, and there clearly are filaments in that area. But in any case, there are also some filaments up here in the northwest, as well as around the eastern limb. And you can see sunspot 2811 not quite yet vanishing. On this imagery, I assure you it will lose its name today. And you can see the KP index here, the measurement of global geomagnetism, having ramped down and down and down over the past 3 days. And thanks for leaving comments, Amp Mods and TJ Red K1272. TJ Red K1272, you're in timeout for spamming our comments and suggesting that we're willing to purchase subscribers, followers, views, etc. Not going to happen. You've received a 10-minute timeout for spamming our comments. Again, there's the KP index over the past 3 days. Perfect timing here to watch it ramp down from a G1 geomagnetic storm, down to a KP of 1. Quite silent geomagnetic conditions indeed. Next, the real-time solar wind. Current conditions are 2.36 protons per cubic centimeter in terms of solar wind density, solar wind speed, 344 kilometers a second, basically solar minimum conditions there. No major issues to report in the BTBZ or the phi angle, which are the top 2 panes. Next, some geospace magnetosphere movies, and we're showing you the density today because of the extremely low density of the solar wind right now. Keep in mind this shows low density in white and high density in dark blue. It's 4 hours of data courtesy University of Michigan. We show it daily because the archival data is not yet publicly visible. Here's the pressure, and you'll see very low pressure caused by a combination of low solar wind density and low solar wind speed. This is in nanopascals, and it's a great moment to take a sip of your coffee. What's in your coffee? Today, mine is Colombian organic, along with some cocoa and cayenne pepper, as I like to have religious experience when I consume foods. I like my food to be so spicy that I see God and go into shock. Yes, I like the very hot, folks. Here's 4 hours of ground magnetic perturbations, and we show this daily as well, since you Earthlings are attempting to survive a geomagnetic excursion. While we've got 2 North Poles, and the South Poles left the Antarctic continent and entered the southern Indian Ocean. Thanks to our viewers on Twitch, by the way. And we are streaming live right now. It's twitch.tv/smAsho. It is my favorite mobile streaming platform. It's very convenient and very well designed. It's why we like to stream there. And if you're wondering why we stream live to Twitch and put a lot of daily space weather videos on Twitch, the reason is, folks, is because I'm not only smAsho, but I'm also a client. And so after I create these videos, I watch them on a larger screen. I'm also the editor at large. So if I make a boo-boo, I have to correct that in the comments section, or even sometimes make a whole nother video retracting or correcting what I'd said. Retracto, the smAsho alpaca. Retracto, we're not going to defraud our viewers. If you enjoy the content on YouTube, don't forget to press like and subscribe. Thanks to our new subscribers, as well as our loyal pals who expected to even reach 100 subscribers. I certainly didn't. As, again, we started making the videos because we saw a niche. We realized that nobody else was covering the correct data sets or producing the videos in a way that is consistent with reality. And so here we are, a few years in. We're also on BitChute, thanks to our BitChute subscribers as well. And let's do a cosmology segment. Today's cosmology segment should be pretty interesting, as it should feature some stories here at the Smash News Network, least busted name in news, that should interest all kinds of viewers. Friends, foes, science noobs, science pros, even your neutrals might be interested in this. How about tidal tails on the Hyades cluster, which is located only 153 light years away, by the way? A huge cluster of stars appears to be being pulled apart by tidal forces. Yes, forces caused by the orbit. Things like gravity and inertia cause tidal forces. And there's a diagram of the Hyades cluster. And you can see the way there's this expansion out of 2 ends, forming a line, actually, of stars there. And this is probably all over the science wire. This title is Tantalizing Evidence. Is the nearest star cluster to the sun being destroyed? I'm going to let the article scroll. Excuse me. I'm going to let the article scroll so you can read it. This one is credited to SciTech Daily. So an interesting article here about the tidal tails of the closest star cluster to the sun, the Hyades. And here's a small portion of the video. And it's not going to let us go full screen, but we'll show you the segment of the sky that it's in. It is located in the constellation Taurus. So in any case, folks, don't worship the golden calf. No eating of babies will be permitted. And here's another good animation here, folks. I'm going to move this back. Again, the article's on SciTech Daily. Go have a look. And this is the estimation of what was going on 650 million years ago and so on. And I'll scroll the rest of the article here. Feel free to pause. We'll be here when you get back. It's the beauty of video on demand. Now we're going to pick a random number between 1 and 1031. Oh, we want one number. And something's wrong with our quantum number generator, folks. Let's see if it works. I apologize. Today's number is 757. Let's take a look at what number 757 is on the Neil Gorell Swift Bat X-ray Observatory. 757. Is there anything really random in space, folks? Today's is GX5-1. Entry number 757, a low-mass X-ray binary/neutron star. We'll call it a massive radio source. And check out the X-ray variability of this thing. There's the historic graph going all the way back 16 years to 2005. And majorly variable there. You can see even on a daily basis, this upper left pane. Here's a 30-day chart. Let's take a look at it if we can see anything. GX5-1. Otherwise known as 4U 1758-25. There it is on Simbad. And we'll look at it in a few other wavelengths here real quick. Here it is on Pan-STARRS. Interesting, interesting. Here it is on the 2-mass, the infrared light. By the way, Pan-STARRS is some bands of visual optical light. So there it is on the 2-mass in infrared. And let's take a look at it on Chandra. Chandra, it may be interesting. Actually, let's take a look at Swift Bat Flux first. There it is on the Swift Bat Flux, the Burst Alert Telescope. Here's the XMM Newton, the multi-mirror project, and here it is on Chandra, I think. Great view of it there in Chandra. I would also note the way the X is well off of this dark region here. So there's a region that lacks X-rays, and the crosshair is on this. An interesting object to say the least. Highly variable low-mass X-ray binary/massive radio source known to some as a neutron star, GX5-1. And let's talk about Hoinga. Hoinga. Check it out, folks. It's quite spectacular. It's the Hoinga supernoval remnant, as it's entitled. You're looking at it in a few different frequencies here. This is, I believe, radio and X-ray composite imagery. So this is going to actually go into our forum shortly. The Hoinga surprise, an unexpected supernova discovered near the galactic plane of the Milky Way galaxy. And this one is very large. And there you can see an example of how big it is. Again, I'm going to let the article scroll here. This is important in that it is the brightest X-ray source in certain bands. So I don't want to spend too much time on it, folks. This is integrated into the Daily Space Weather video. But we're going to have to update smashomash.com/forum as a result of this one, because we're keeping a catalog of certain objects. And I don't know why we're on COVID-19, but let's talk about our mission. And if you want to read the rest of our mission, head to smashomash.com/forum/mission. Number 5 is to publish scientific papers in a multidisciplinary manner, including but not limited to science such as spectroscopy, chemistry, astrophysics, health, wellness, longevity, cosmology, biology, and more. And so I just wanted to let our viewers know that I'll be explaining the mechanism behind the solar sunspot cycles, a problem with the current measurements of the most relevant solar data, as well as possibly a third one about cosmology. So I don't want to reveal too much in the Daily Space Weather video about this, because I don't want my idea to get stolen. Actually, several ideas to get stolen. And if you haven't checked out smashomash.com/forum yet, the official forum of the Smash News Network least busted name in news, head to smashomash.com/forum. And we're talking today about the Cosmology Forum. So the Cosmology Forum, and thanks for posting on the Cosmology Forum, Terry Shepard. Thanks for posting space distance. But today we're going to be talking about the MOST, as we have a forum specifically about the MOST in space. Whether it's the largest object in the solar system, or the largest planet in the solar system, or the strongest radio source in the sky besides the sun, Cygnus A. We've got a whole multi-page list here, and we'll be updating this to include the strongest specific band X-ray source known as the Hoinga. So that will be appearing soon. Check out our other forum topics as well. We've got forums on, what do you call it? Earth and geophysics. Earth and geophysics? Is that what we called it? Geophysics. Yeah, Earth/geophysics. There's a free-for-all. There's a general science forum. There's one on our content, which is barely even populated. Again, smAshomash.com/forum. And if you want to read about the mission, smAshomash.com/forum/mission. One of our missions is indeed cosmology. Here at the Smash News Network, least busted name in news, we're concerned about cosmology because of the implications to your daily life, especially. And that's today's cosmology segment. Let's continue on with some data about things like electrons. Here's the electron flux over the past year. And we're in a pretty moderate range here. Here's the 3-day chart as measured by the GOES 16. Briefly made it into warning levels yesterday, and this red dotted line coincides with 1,000 pulse flux units. This graph is actually showing electron density. You can see particles per centimeter negative squared. Here's the forecast, and NOAA is forecasting for pretty level electron flux here. The yellow diamond is the observation, and the green box is the forecast. Next, we're going to show you a visualization of the air column from about 12,000 miles through the inner Van Allen belt from the GPS satellite you may be communicating with down to your handset. It's the total electron content forecast. It's basically showing you where the inner Van Allen belt is located. The inner Van Allen belt. Having trouble speaking the English language today, folks. And this will show you where GPS errors are most likely to occur, which is typically around the equator at noon. When we see very low levels of electron flux, as we'll see when the coronal hole wind stream arrives late tomorrow, we'll see a less organized total electron content forecast. And it all has to do with geomagnetism. Here's another diagram of the atmosphere, folks. It's showing you things like the F ionosphere layer, which is that red F over on the right side of the screen. You can also see the D ionosphere and the E ionosphere and the troposphere, where all of your weather occurs, and the penetration of electromagnetic radiation, and the temperature on the left. So here's just the ionosphere, just that slice around 300 kilometers of altitude. It's the F layer in vibrational frequency in megahertz, which is millions of vibrations per minute. And we see some charge downs there on the nighttime side, making it an F layer. When you see a red blob, that means it's an F layer. And a yellow blob, wow, sudden discharges there. So some major discharges. That's a pretty anomalous ionospheric effect that you saw there. I'm going to let this play through a second time just so you can see that again. I want to see it again. And we see some rapid charge ups and charge downs going on in the ionosphere. Keep in mind the resolution is only 1 megahertz. Don't be megahertz if you don't understand the physics. Just watch our channel. Perhaps things will start to get connected. And by the way, everything's not connected, but some things are, which is why we have the term connected. Also, everything's not electric, but some things are, which is why we have the term electric. So we do see some anomalies here. Some unexpected charge-ups here, some large blobs of high vibrational frequency over places like the Central Pacific Ocean. And here we're coming into the last few hours of the ionosphere. This data is, by the way, by Australian Government Bureau Meteorology. And here in the last few hours, we saw this big charge down. A large portion of the, and there you see another oddity there. The entire polar region making it up to 2 megahertz all at once. Anyway, here's the latest image. We don't want to tarry too long. There's the latest image from 12 o'clock Universal Time, 12 noon, coming at you a little late today. Sorry for the lateness. It's all smAsho staff's fault. Ask smAsho staff why we're so late. It's all her fault. She's getting a pay cut as a result, folks. Just kidding, folks. All right, so here's the jet streams of the eastern world. And we see tripled up jet streams in the northern hemisphere and extreme meridional jet stream flow in the south. Here are the jet streams of the western world. And pardon my stoicism when I'm reporting on things that are quite insane. I'm able to shoot a foul shot with somebody screaming in my face, if you're wondering. Let's just say I work well under pressure. Jet streams of the western world are looking pretty jacked up as well. We see some extreme meridional jet stream flow over here, coming down from Bermuda, blowing essentially backwards over the north central Atlantic Ocean. And continuing on with meteorology. And we were looking at snow depth. Let's bring up pressure maps. Here is the pressure map currently, and we're going to advance this to tomorrow. This is where the Euro forecast expects pressure to be at 12 noon tomorrow. Looks like some major pressure gradients there over eastern Canada. There's the GFS forecast. There's the Euro forecast. Again, GFS, Euro. And that is for 12 noon Eastern time tomorrow. And we see some severe lightning storms here. Right over Nashville. Shout out to our Nashville viewers. Nashville, Tennessee, having an extreme lightning storm. Right over the center of town. There's thunder rolling in. Nashville. And if you're around that area, go take some time-lapse photography of the tops of these thunderheads. Huntsville, Knoxville, Chattanooga, perhaps. You may see some sprites, red elves, or other weird stuff going on above the thunderstorms. And lightningmaps.org will actually calculate the propagation of thunderclaps. So there you can see the expected thunder propagation at lightningmaps.org. And there are those strong storms moving east-northeast across Tennessee. They're about to cross into Kentucky, and then Virginia, West Virginia, eventually probably Maryland, assuming that their vector continues. Some snow falling in northeastern Minnesota and Montana and Wyoming and Colorado and New Mexico, indeed. Also South Dakota seeing some heavy snow. Here's what's going on in the cloud layer. And you can see the rapid cloud formation here, sudden cloud nucleation forming there, and there's a massive pressure gradient striking. Here's the pressure gradient in water vapor, and you can see that dry mass of air there pulling a whole bunch of water off of the ground, forming it into clouds. As the atmosphere attempts to reach static equilibrium, folks. That's today's meteorological term, folks. Static equilibrium. Do you have a bunch of static on your YouTube channel? Is your YouTube subscription feed full of static and nonsense? Well, we hope your YouTube feed reaches static equilibrium by watching our videos instead of nonsense on YouTube. Here is the most current set of ground-based solar observations. It's like less than 2 minutes old. 2 minutes and 22 seconds old from Udaipur, India. And you can see one of the filaments up here. You can't really see the filaments that are in the center part of the disc here. It all has to do with contrast. You can barely see sunspot 2812 on the imagery. Some filaments up here and down here as well. It's time for bonus features. But first, I'd like to thank the real stars of the broadcast, our patrons. Please consider becoming a patron at patreon.com/smAsho. By the way, we're having a slam poetry contest in the month of April. We'll give away a free 1-month $3 intro tier membership to whoever wins the slam poetry contest, so get involved in that. More details on that later. We'll announce it officially on April Fool's Day. Thanks to the Smash team. Again, our Patreon is patreon.com/smAsho. Thanks to the Smash team. Please leave comments. Please share. Please tell your friends, foes, science noobs, and science pros about the content. And here come bonus features in the form of the ultra-high resolution magnetogram and solar intensitygram. And thanks for leaving a comment, Terry Esty, who says, had to smile at your comment on your coffee, cayenne and coffee. Very interesting today, especially cosmology segment. Again, we try to keep it interesting. Here is the high-res view of especially sunspot 2812. And you can see it still only has one North Pole-oriented umbra. And sunspot 2811 is going to lose its name today. It's no longer a sunspot. Here's why. It's got no umbrae, folks. It's lost its umbrae. But 2812 remains, although it has also shrunk. Here are some additional views of my favorite star, local yellow dwarf known as El Sol. Given a minute, it's 94 angstroms. It's one of the ionized UV emission spectral states of iron. And it will play, I assure you. And it looks like we have some oddities in the data there. You can see a little bit of flaring toward the beginning of the video. That was just the initialization process that we were seeing there. The sun wasn't really reversing its rotation, folks. Objects like the sun and the planet don't just reverse their rotation. It's a ridiculous and silly idea. And we've got some more views for you. A close-up of the magnetic fields. So zooming way in to former sunspot 2811, which is on the right, and sunspot 2812, which is on the left. Fantastic view of the magnetism of those. I'll let it play through a second time before we close things out with a 171 northern solar hemispheric view. How about a second time? Fantastic view of that. Is that lattice-confined fusion occurring? Well, I would have to say it probably is. Lattice-confined fusion may be causing confusion. Thanks to Dr. Robitaille for producing the fantastic videos on Sky Scholar. Pierre-Marie, drop me a line. And we'll see you next time. Thanks for tuning in once again, folks, to the Daily Space Weather. I've been your host, Dan, a.k.a. smAsho, reminding you to stare at the sun, attempt to understand the physics, don't drink, and if you do, don't drive. Welcoming you to the Neo-Renaissance, and well wishes to you, our viewer. May that solar wind be at your back.